This is chapter 5.3, day 3. We got to finish up the different types of techniques of solving equations. Remember, we started off with the idea of just solving it for angles, because remember, we're solving it for an angle here by setting a trig function equal to a ratio. We could use our unit circles. We also have to ask ourselves, when is a trig function positive or negative? And a lot of times we know it's more than one time to a value, so we always had more than one value. And then we brought on the fact that you could go around the circle an infinite amount of times. So we added a 2k pi or 360k onto each one of those. And then we went into the fact that we had a factor sometimes. Other times we didn't want, because we don't want to divide ever, we changed some of our identities into the same variable or the same type. So we were able to use the Pythagorean identities, the double angle identities, all of those things. Those can roll into here. And now today we're going to look at this one and say, hey, this looks really familiar, at least as a setup, I think, to one of the Pythagorean identities. Now, I'm going to take a sidebar here. I'll erase this at the end. But I think everybody would agree that sine of x plus cosine of x, or squared, sorry, is equal to what? Equal to 1. And if I went through and I want a tangent, divide everything by cosine, right? So if I divide everything by cosine squared, doesn't this equal tangent squared? Plus 1 equals secant squared x. I mean, I'm just moving it. We've done this back early chapter 5 before we went to solving. But doesn't that look really close to what we have above? There's a secant, there's a tangent. The only thing is they're not squared, right? So could I'm going to erase the top line for sure. Could I use this piece? I'm going to move it over here, shrink it down. I want to keep that. Could I use that somehow, eventually, with my secant x plus 1 equals tangent x? Well, first of all, our original problem, is not squared. The formula that I want to use for the Pythagorean identity is squared. But what I do to one side, I have to do to the other side. So let's square both sides. Now what happens when I square the right-hand side, or left-hand side, sorry? What do we know is going to happen? Can I just square secant in 1? No. Hint, a lot of people did that on their last quiz. A lot of people forgot that you actually have to separate and FOIL or use the pattern. Remember, the pattern is the first one squared, yes? Then you have to multiply them together and then multiply it by 2. So 1 times secant is secant, times it by 2 is 2 secant x plus 1 equals tangent squared x. Now, notice that I got a lot of secants here, but I also have a tangent. So there would be potentially a way to change them all into one function. What do you guys want to get rid of? What would be the easiest one to get rid of? What's all by itself on the right-hand side? Tangent. Get rid of tangent. What does tangent equal? What would I have to do with this one? Bring it to the other side. So doesn't this then equal secant squared x plus 2 secant x plus 1 equal secant squared x minus 1? Isn't the whole entire problem now in secants? And what's the coolest thing about when I did this? Am I going to have to actually factor? Because right now, I think everybody should recognize there is a quadratic on the left-hand side. But by taking that tangent squared x out and replacing it with the secant squared minus 1, what's going to happen to the secant squareds? They're going to cancel. I'm going to be able to subtract it. Subtract a secant squared x. Secant squared x. Gone. Gone. 2 secant x plus 1 equals negative 1. Which means, now can you solve it? What do I do to solve? Minus 1. 2 secant x equals negative 2. Divide by 2 secant x equals negative 1. What is secant again? 1 over cosine x. Now, there's a couple different ways. Again, we can handle this. We could take the reciprocal of both sides, because when you got two fractions, you take the reciprocal of both sides, or aka to the negative 1 power to both sides. Or you could cross multiply, because 1, or negative 1, is really negative 1 over 1. Hopefully everybody would recognize that when I take the reciprocal of negative 1, it's still negative 1. And it's pretty easy to solve for cosine of x equal to negative 1. Let's do this in radians. If it doesn't specify, you should be doing things in radians. So, where is cosine negative 1? Straight back, right? Well, what is it? It's pi. Now, it also did not tell us what? Didn't specify radians or degrees, so we go with radians. It also didn't specify that it wants it between 0 and 360 or 0 and 2 pi. So therefore, it's not looking for a answer, it's looking for all answers. And so we add, well, I'm not going to add 360k to a pi, it's 2k pi, right? And so there is your answer. That is the last of our components of the different styles of solving. Okay? So, always factor, never divide. Functions. Make sure you bring everything to one side if you have to factor, or switching things out. If you see a sine squared or any of the trig functions squared, you can use your Pythagorean identities. You could try to get everything to one type of function. Make sure you are solving the function to a ratio, so you can technically take the inverse. Find out where is it positive and negative and how many times it's positive or negative. And make sure you do things in radians or degrees as it states. And then also, if it states between a certain degree or a certain radian, make sure you find the answers that are there. So the homework is on page 331, 21 through 29 odds. Have a great day.